This video is on experimental probability. The experimental probability is also known as the relative frequency of the outcome. Generally, we write it as a decimal, but it can be written as a fraction. Now, experimental probability is based on an experiment that's happened. Now, the idea of the probability is exactly the same as theoretical, where it is the probability just equals the number of times something happened, so its frequency, divided by the total number of trials. So first example, Larissa took 43 shots at a netball goal and scored 29 times. Estimate the probability that she will miss her next shot. So the probability that she misses the next shot would be 43 minus 29 because she scored 29 times out of the 43. Out of 43, 43 minus 29 is 14. So she missed 14 out of the 43, so the probability that she'll miss again will be 14 out of 43, based on what she'd done previously. And then as a decimal, you'll find that's approximately 0.326. Example 2, a marketing company surveys 80 people to discover what brand of shoe cleaner they use. Estimate the probability that a randomly selected community member uses Bright and then Cleano or No Scuff. So for first one for Bright, we just look at this table here with our information. And our total here is 80, it tells us that in the question. So for Bright, you've got 22, so the probability that it's Bright, I'm just going to use a B there, would be just 22 out of 80. Really simple, and as a decimal, 0.275. Then B, Cleano or No Scuff, so the probability of Cleano or No Scuff. We've got 20 Cleano, 11 No Scuff, so we add those together out of the total. So we'd end up with 31 out of 80, which is, as a decimal, 0.388 to 3 significant figures. Once again, with this, you can leave your answer as a decimal or a fraction. It doesn't matter. You'll still get the mark no matter which way you do it. Just read the question. Just make sure it doesn't tell you if it wants it in a particular way or not. Then example 3. A survey was conducted to investigate the breakfast habits of teenagers. Use this table to estimate the probability that a randomly selected student is male and regularly eats breakfast, or is female or regularly eats breakfast. So when we have a two-way table, what's always a good idea is to add a total row and a total column. So males, we have a total of 155, females 145. How many regularly eat breakfast is 140, and does not regularly eat breakfast is 160, and then our total overall will be 300. So use this table to estimate the probability that a randomly selected student is male. So male, our total for males was 155, so the probability that it's male would equal 155 out of the total, which is 300, which, if you want to do that as a decimal, would be 0.517. B, a male and regularly eats breakfast. So male and regularly eats breakfast means we're looking at this 87. So I'm just going to put male and eats, which is going to be 87 out of the 300, which is 0.29. And the last one is female or regularly eats breakfast. Now we want is female or regularly eats breakfast. So in our table, this will be the 3 that I've just circled in purple. So even though the 87 is male, because in the question it is an or, means they don't have to be female. It's just including the regular eats breakfast or female. So these are the 3 that correspond to that in our table. So probability female or eats, just to simplify, and we will have 87 plus 53 plus 92 out of the 300, which equals 232 out of 300, which, if you wanted to put that as a decimal, you would get 0.773. Now with this one, as it's an or, we could have used our addition law for probability. So we could have done the probability of female plus the probability that it eats breakfast regularly minus the probability that it's female and eats breakfast regularly. Probability of female, if we look back at the table, female is 145 out of 300. Eats breakfast regularly is 140 out of 300, minus the intersection, so female and eats, which is 53 out of 300. Work all that out and you will still end up with the same, 232 out of 300. So if you've got a table, you can just use a table and work out which numbers you need exactly, or you can use the rule that we've used previously. And that is experimental probability.